Let's go. Number 18. All right, it's in blue, so we're gonna go given. Okay. Now this is all kind of in our way, so I'm gonna erase this since it's from the last problem and just kind of, if people are writing it. Okay, and then this one was distribution. Good enough. Okay. So now I got enough room over here. I'm gonna move this radical. It bugs me. I like it out here. Okay, so given. Alright, now what are we gonna do?
1 plus 8. Is it 2, right?
What?
Separate them into 2, right?
Separate them into 2? Okay. So like you were doing 1 plus 8,
Yeah.
but you were doing like 18. You're going 3 goes into 18, right? And then does 3 go into 72?
Yeah.
But what is 7 plus 2? 9?
Yeah.
Right? So it's like 1 plus 8 is 9, 7 plus 2 is 9. So both 9s are divisible by 3, right? So we're good. So we know 3 goes into it. But before 3, what goes into it? What numbers?
Oh, 2.
2, yeah. So don't forget the 2. So always start with 2, the lowest number. People are like, why does it matter? And I'm like, because if you start getting them in different order, right? You go 3, and then you're like 2, and then like 3, and then like 2. And you're like, when you go to pair them up, it's like, well, it's this one with this one, and then it looks really funky. It's not as easy. Does that make sense?
Yeah.
Okay, so just do all your 2s, then your 3s, then your 5s, then your 7s, and so on. So we got 1, 8, 7, 2. We're going to start with 2. And that's called what?
Definition of prime factorization.
Nice. So you remember the words. Okay. 2 goes into 18. How many times? 9. With nothing left over, right? So how many times does 2 go into 7?
3 plus 1.
So 3 times?
Yeah.
And then there's 1 left over?
Yeah.
So then how many times does 3 go into 12?
4.
4. So see how that's short division? If you use your colors, some people don't need to use the colors. And you don't really need to once you get the hang of it. But what's nice about using the colors is when you look back at it later, you go, oh, that's how I got the 9. That's how I got the 3. That's how I got, does that make sense?
Mm-hmm.
All right, so what number's next? Should we still use 2?
Wait. Aren't you doing 2 goes into 12?
2 goes in 2. Holy cats, yeah. Ooh, thank you. We almost messed up, huh? So, did I say 3?
Yeah.
My bad. So 2 goes into, I think I saw that 3. Ooh, that's confusing, huh? So bring that guy down here, put it in a parenthesis. Alright, so 2 is 9, good. 2 times 3 is 6 with 1 left over, good. 2 goes into 12, not 4 times, 6 times. There we go, thank you. Thank you. We don't want another mistake I have to go redo this thing about, right? Oh, by the way, I redid that, put it back up, and deleted the old one. Said thank you for finding my mistakes. You get extra credit.
What?
What? So tell Ben he gets extra credit, not you. No, I'm just kidding. I'm funny. Come on, you're supposed to laugh. Like dumb jokes. 2, that was worse than laughing, that face. 2 goes into 9 how many times?
4.
4 with how many left over?
1.
1, okay? So 1 and 4 there for some reason. So we had a 1 up there, right? So 1 and 3 would be 13. So 2 goes into 13 how many times?
6. I mean, yeah.
6, good. And then that's with how many left over? 1, right? So that's 1 and 6. So how many times does 2 go into 16? 8. All right. Okay, do we use 2 again?
Yeah.
Does 2 go into 4?
Yeah.
Twice, right? 2 go into 6?
Yeah.
3 times. 2 go into 8? 4 times. That was an easy one, so we didn't need to change the color. Right? Alright, do we use 2 again?
Yeah.
Alright, why not? Does 2 go into 2?
Yes.
Once. Does 2 go into 3?
Yes.
Once. With 1 left over, right? So does 2 go into 14?
Yes.
Yes.
7 times. So is that helping using this little short division? Using those little carry the 1s, carry the 2s? And you get a lot faster with your division, right? Now, could you be using a calculator on this? Yeah. Okay? So, but I like using my brain. Alright, so does 2 go into this?
Yeah. Not really.
Well, I mean, any number can go into it, but evenly. Is it even? No. So then 2 doesn't go into it, right?
But 3
So that's the truth. But 3 does. How come?
Because 1 plus 1 is 2. 2 plus 7 is 9.
That's it. So,
Get it now.
I do.
is that making sense a little bit?
Yeah.
On the 3s? Good. How much? You've learned more in one day here than you learned all semester at Auburn or wherever the hell you
At
were.
Enumclaw, yeah.
Enumclaw. Ha! And that's on film right there. All right. We busted.
Don't listen to
you.
him,
No, I'm
he's
just kidding.
clinically
All right,
insane.
all right, so what is 3 times, or what 3 goes into 11 how many times?
3 times.
3 times. With how many left over?
2?
A 2, good. So then I'm changing that 7, right? So how many times does 3 go to 27?
9. Wait. Is
This is the
Yeah.
titties.
9.
Okay. Good. I knew the end, I just ran for you, right? Okay. And now this I don't really need to change the color because 3 goes into 3 once, 3 goes into 9 3 times, right? And then does 3 go into 13? No.
Well, not evenly.
Not evenly, right? So that's what we want, evens, right? Does 5 go into it? Does 7? Does 11? Does 13? See? So, and that's what's going to happen. You're going to just keep climbing the ladder until that next prime goes into it. And you might end up with 31. You know, you might end up with 50. Oh, is there a prime in 50? 59? But whatever. You know what I'm saying. You get to 1, you're done. Okay, here we go. Circle all your pairs. So I take a color that I don't have up there.
Black.
Black. Let's use black. Good choice. And there it is. There it is. There it is. So, what's really nice here is that I'm going to take this 3 down to here, right? And then I'm going to take this and make a 2. Okay? And then I'm going to take this down and make another 2, so they're multiplied. And then I'm going to take this down, that's a 3, right? And then there's one number not in a circle. What number is that?
13.
Right. So we're going to leave that in the radical. Okay? And that's what we call what?
Or radical simplification.
Yes, radical simplification or simplifying the radical. Either way. So on the state test, it would sound smarter if you say simplifying the radical. But it's just easier to write radical simplification. So
I couldn't say it either.
right. So it is easier to go with the opposite. All right, now we're going to put these together, right? So let's go with purple. And we got 3 times the quantity of, what's 2 times 2?
4.
And 4 times 3.
12.
So we got 12 square roots of 13. And that is just simplifying. And then we're going to do distribution, right? Where we actually push it through. What's 3 times 12? And if we don't know it, what's 3 times 10?
36.
36. Good. All right, so we got 36 square roots of 13. And that's distribution. I don't know how I turned the blue from red, but it was magic. It's magical. Questions? Better. What? I don't even know how to do it, so.
It's like you wanted me.
Right?